So the Mojo Global organization is a collaborative non-profit and hosted by the Linux Foundation. The Linux Foundation are the legal entity, and they allow us to hand off the administrative burden of accounting, HR, and marketing, and then let us focus on the collaboration exercise. There's several levels at which users and contributors can engage with Mojo Global. If you'd like to represent your country on a strategy board, this allows you to dictate the strategy of Mojo Global and the direction of our development. If you're an expert, you might like to sit on the advisory board and provide input and suggestions into how our roadmap is developed. The input of the strategy board and advisory board is handled by our management board and the assistant directors. The management board is responsible for delivering a strategic plan that sees the Mojo Global initiative succeed. On the left-hand side, the Technical Steering Committee is responsible for the maintenance of our code, our documentation, and the science that is used by the Mojo Global community, and anyone can participate in the development of these resources. So your engagement can be scaled to your ambition. But if you want to become involved as an individual, here's a series of steps that will allow you to get to know our community, get the Flint up and running, and potentially even make contributions to the ongoing development of the Flint and our other MRV projects. Starting at the very top, we highly recommend that you join our online platforms, and I'll show you some links to them in a second. Then you've got to introduce yourself, say hello, and we can explore how we work together. You might like to join one of our working groups, attend one of our meetups, read the documentation, and watch some tutorials. Finally, there are some examples that you can run to get a handle on how the Flint works. And if you are interested in contributing to the code itself, you can file an issue if you have problems, potentially resolve the problems by submitting a patch, or propose a project or collaboration. I want to be clear here, though, that you can choose the level of your engagement. It might be as simple as introducing yourself, or it might be proposing a collaboration to the Technical Steering Committee or the Management Board. And you might have different people in your organization engaging in different ways. So your developers might like to join the developer community, read our documentation, whereas our policymakers may prefer to engage at a higher level and discuss MRV implementation roadmaps. Our main landing point of contact is the Mojo Global website. There is existing resources about our mission, how we work, the Flint itself, and how you can get involved. There's a news section with ongoing updates, and we have several emails by which you can contact us. The first email, Mojo, info@mojo, is monitored by the management board. The TSC is the Technical Steering Committee, and we have an additional address for mentorship. And these are for collaborative projects where members of your team or potential users want to learn the skills and collaborate with existing users. We have a Slack community. Now, for those of you that don't know Slack, I'll go through this quite slowly. Slack is an online community board where you can join one or more channels related to the data sets available, the user interfaces, tutorials, and documentation. And we have about 250 members ready to help you on your journey. Now I'll share this link in the chat, and I encourage you to join up. There is a really active community of interested and engaged people online that want to see the Mojo Global organization succeed and really here to help. We're also experiencing very rapid growth. So this number of people that have joined in just the last year alone has more than quadrupled our Slack user base. And we think it's neat that there's so much excitement in this area. For those of you that don't want to use Slack, email is absolutely fine. and you'll have access to these slides afterwards in order to follow any of the links that I share. The other place that a lot of collaboration occurs is on our code base, which is hosted at github.com. Now, this is where you can find all of the open source code contributed to the Mojo Global project. This includes the Flint, the reporting tool that we saw on day 2, some of the data sets and that have been assembled by different contributors, and also the processing code used by Julian in the Chile example. These are several of the key pages of our GitHub platform. At github.mojo Global, you'll find our list of repositories and 2 primary pages, About Mojo.global and the Flint. In About Mojo.global, you can see the wiki, which has frequently asked questions, including the organizational structure and how we can collaborate. On the Flint, if you have trouble getting up and running, you can use issues to file requests for help or find areas that other people have experienced difficulties before. And this is a really good way to get to know the Flint, and if you encounter troubles, it means that problems that are solved for one person are available for other people to learn from. And in this way, we share the capability that developed by the MRV community around the world. I also want to point out the importance of the people. Contributions to GitHub are public and identifiable, and so you can get credit for your contribution. We celebrate our community and encourage people to annotate their to attribute their contributions so that they can be they can take pride in the work that they're undertaking. Mojo Global as an organization wants to support the next generation of MRV systems around the world. So we can provide resources and training and experts, but we need user engagement. The kinds of collaborations that we've seen in the past have led to the development of the generic carbon budget model presented by Werner, Julian's pilot in Chile, a compilation of global data sets, and even algorithmic processes to develop land use change maps. In particular, one I'd like to highlight that's really exciting is a group of machine learning experts who have secured funding from Google, and they're using AI to predict the risk of deforestation. Now, just to make this clear, this is separate from the Flint. It's something that you would use to prepare your land use maps. But the point I want to make is that the project itself is open source. Anyone can access this and apply it in their own country. If you'd be interested in making contributions, we accept technical contributions in terms of documentation, supporting evidence and policy considerations. We need community contributions to deliver training. We need user feedback. It's really important that the Mojo Global project addresses the interests of the MRV community, and we want to know what you need to know. It's also a way for you to meet other people, and this collaboration is what I see as one of the major strengths of Mojo Global. Rather than working alone in your team, you can connect with other people around the world that have experienced the troubles that you're facing and provide the means to find support. The collaborative maintenance of the Flint code base also allows users to review the code to understand what's going on and submit bug reports whenever this is an issue. You can suggest additional functionality, including new features, and make suggestions to the direction of the development roadmap. So an example of this from day 1 was the desire to integrate Flint outputs with IPCC tools. And Rob made the point that this is something that can be built now that we know that people are interested. Lastly, we also need help support in outreach. And this is attending seminars like these, preparing content, but also disseminating it, the slides and videos through your teams, updating the website, writing newsletters, and celebrating the success of your MRV ambitions. The primary theme that I think is important here is that the Mojo Global as an organization requires all kinds of contributions. And this can be mentorship, documentation, and science, or it could be around implementation in your country. You could help with interface design, and there's people to support deployment and optimization and maintenance. We organize these contributions into working groups, and these working groups are collective subgroups within the Mojo Global community, focused on a single topic or theme. This makes it easy for you to find people that can answer your questions, and also provides avenues to engage with other people and make contributions that you think are helpful. Often these working groups hold regular meetups. One of our more popular groups is the Documentation Working Group, who meet every 2 weeks. It's a friendly community, and they more or less talk about the work that they've been undertaken and synchronize on next steps. The Technical Steering Committee meets every month, and this is an open meeting to anyone that wants to attend. It's a great place to make introductions, and we often present a feature project to highlight the ongoing development within our organization. There's also an implementation working group that meets about quarterly, and this is focused on the trials of as coordinating a project, an MRV implementation project, often at a national scale. These meetups are led by working group coordinators, and they're open to anyone that wants to attend. You can contact the coordinators to discuss contributions and even mentorship opportunities. If you'd like to start a new working group, you can submit the terms of reference to the Technical Steering Committee, and we can find people that are interested in working on a similar topic. We have documentation. It's comprehensive, but it's difficult to know what you need to know. So you have to we desperately want your feedback. Again, these links will be shared afterwards, but you can find the technical docs at docs.mojo.global, the wiki I described earlier for frequently asked questions, a governance model of the Mojo Global organization, and a description of how that contribution model works. We have a YouTube channel with tutorials, including an introduction to the GCBM, how you can install it, the science behind the GCBM, and how it can be adapted to your specific implementation needs. And there are training packages available online that show increasing complexity from very simple, and they're a very simple example on the left here that contains 3 pools and shows a change in the stock over time. There's the pre-processing repository that Julian used to develop his MRV pilot, and additional work on the Chapman-Richards module, modules such as the Chapman-Richards forest module and the agricultural soil models. These modules and training package exist in isolation, and it often requires some familiarity to understand how they can be combined. The important part is that the modules exist in under an open source license, and they can be used by anyone. Participation is free, and it means that the contributions are voluntary. So anything that you develop is yours to own, but we encourage you to very much please share any improvements. These are just 2 short examples about why contributing to open source is important. So on the left, this is a report from the UK Cabinet Office that shows the lifetime cost of software. Importantly, it's more than just this line item cost of software. It includes the effort required to evaluate different options, the cost of setting up a proof of concept, the cost of training, support, and scaling. Importantly, in an open source community, these costs are significantly reduced. They're not zero, it's not totally free. You have to invest in your team and your community. But where previously you would pay for proprietary support and administration, the support costs are significantly reduced because you can leverage the lessons learned from others in our community. For developers, what's in it for you? The fixing bugs collaboratively reduces overall risk. That means that problems solved by one person are quickly made available for everyone. This results in shared development resources for reduced cost and shared training resources to build internal capacity. Importantly, within our community, there's options to find mentors. If you're if you're already an expert, you can teach to learn and grow your reputation. The reason I'm encouraging this is because your participation is good for Mojo Global. In addition to using our software, participation in our community gives you the opportunity to leverage our network for visibility and discuss your system and implementation with other users and contributors. As a contributor, you can provide feedback, improve code and documentation, and suggest new features. Or as a board member, you can contribute to the strategy and technical direction of our organization to make sure that the projects we build are fit for your needs. An important part of our community is our mentorship programs. In 2021, we've successfully placed 14 participants with mentors in different communities and different organizations working across a range of projects. These are three of our most popular. One led by Werner, working on the development of environmentally sensitive growth curves. One in the middle, led by me, working with web developers to improve the interfaces that people use to interact with Flint. And lastly, the Deforestation project I described previously. These mentorship programs are often supported by small amounts of money from funds such as Outreachy, Google, and the Linux Foundation. If you'd like to participate as a mentee or a mentor, then we really encourage you to email tsc@mojo.global and express your interest. And lastly, there are several opportunities for collaborative implementation. We've worked previously with the Australian Government, Natural Resources Canada, and definitely the UNFCCC to work to build out the features that our user and community needs. Some examples of this are the development of new modules, reports from subject matter experts, and training of new users. And one of the more popular projects has been the consolidation of globally available datasets and model calibrations. Now, these datasets are often an important resource, and they may not be as accurate as your local and local land use cover maps, but they're a great place to set that baseline. And one of the themes that I think has come through in our training session, hopefully, has been to start simple. These global datasets are a way for you to get off the ground and provide us a baseline for you to improve upon. I want to also talk about a future collaboration with the IUCN. We're applying the Flint in 10 new countries to explore the opportunities for forest and landscape restoration. But we always need new experts, local consultants, and project officers. Again, reach out and let us know if you're interested in participating. There are also current opportunities. If you're interested in working with us on a paid contract, please let us know. This is supported generously by the UNFCCC, and if you're able to register with the UNFCCC on the roster of experts, we'll be able to let you know when new opportunities arise. I might pause here for a minute and ask Rob if he's able to jump in and discuss the potential modalities of engagement with the Mojo Global Organization.
Great, thank you very much, Andrew. And I think it's a really fascinating thing to start looking at, is how to work with open source. So I'd really encourage you all, please, if you have time, to please put some questions into the chat. Just quickly from a personal note, because it probably does help to understand where people came from. And my history with open source is that I was definitely a very large open source skeptic, especially when it came to government systems. So when I was working inside the Australian government in the 2000s, I liked the concept of open source, but I certainly didn't see where it fitted into the world of national systems and running. And those were the days when we were obviously developing FullCam. And I think Werner's probably got a similar story if he's interested in jumping in at some point. But as we developed the Flint, and as we saw the power of open source, the concepts of the licensing, the concepts of the communities coming together, I did a complete 180-degree turn and realised that open source actually provides a huge opportunity. And the reason it provides that opportunity is that it means that it doesn't cut out commercial options, it doesn't cut out government options, it doesn't cut out NGO options, it doesn't cut out free options. What it means is that all those communities can work together to build something faster, that works much, much better, and that actually allows people to truly understand what they're working with. And I think, as we pointed out in day 2, if you just look at the way that open source software has come to dominate the world's software development and software packages over the last sort of 10 to 15 years, it is a proven and a highly successful model. So I'll, sorry, there's a bit of noise there. Werner, I don't know if you've got anything to say on that, because it is an interesting experience of moving from those histories. And I think many of us still carry some of that, but I would encourage you strongly to work towards understanding open source. It's not just putting code up on a GitHub account and walking off. It's about working with lots of people. That's the important part. It's not just the code.
Yeah, I can add to that. Fundamentally, in Canada, we had the same problem and some of the same experiences. When we started to develop our system, it was much more, there's an open microphone here. It is much more difficult. It was much more difficult to, oops, what happened? It was much more difficult to maintain code, and it was therefore necessary for us to basically protect the code base as a government agency. We have now learned how to, basically maintain the code while at the same time encouraging open source collaboration on projects. And the one point I want to add that Rob didn't mention is that the scientific community is also very much moving towards an open source model. Many of the models and scientific tools that are being developed are now based on open source platforms that enhance and encourage collaboration, and also that give people opportunity to get credit in an open source framework, because it's acknowledged by all that is the better way to go. So, like others have said, we encourage and actively contribute to open source collaboration through Mojo Global, through the work that we've done with GCBM. And in addition, as we will talk about in a moment, Government of Canada has also been providing training opportunities, like the examples that Julian represented for Chile. We had training workshops in Santiago de Chile at the beginning to help that group of experts to get launched with some of these activities. And there have been other workshops held by Mojo Global in various places around the world. So back to you, Rob and Andrew.
Thank you, Werner. I think that's a really good summary. And from my perspective, if I was to summarize it, it's, from our side, there's no way we could have built Flint Pro without the collaboration from Werner. And I certainly hope that the work that we've done as a company with other companies and organisations has allowed Werner to take the GCBM as far as it's taken, and
Absolutely.
now being able to share that with everyone. So it's been an amazing collaboration. The only reason it exists is because we've collaborated, and the future is obviously, I would say, collaboration. So look, without further ado, I'm going to get into this next stage. I have seen a few questions popping up about the SharePoint over the last few days. We all know that SharePoint is a fantastic system, but it doesn't necessarily always work everywhere. So if you can't access SharePoint, please let us know. But we will be loading the slides up onto the Mojo Global website as well, so that everyone can have access to that. And I noticed that Sabine and the UNFCCC team have been very kindly loading the videos up to YouTube. So all of the material will be shared, and depending on your accessibility, processes of your accessibility, please obviously go to the SharePoint as the first point of contact. But if you need something else, please just reach out. I'm very happy to help. So with that, I'm just going to do a few slides on the business models, because this is something that did come up, and so we decided we had better add this into the presentation, just to make some really clear distinctions, and also some understanding of how flexible all of this is. And again, Werner and Andrew and others, if you feel the need to jump in, please just do so. So the advantage of open source software and Mojo Global is that it means, of course, there are some license conditions, but the license conditions are very open, and those open license conditions mean that pretty much everyone can use Mojo Global. They can come in and they can download the Flint, they can download modules, they can do what they want. The MPL2 license that the Flint is under, the only real constraint to that is that if you make improvements or changes to the core Flint, we request that that comes back to Mojo Global. And then if those changes are deemed suitable or they're deemed improvements by the core community, then they can get put into the Flint and the version goes up. And this again is when I was talking about the collaboration and how it's helped us. If we make changes to the Flint ourselves, Werner gets the advantage of that. When Werner makes changes to the Flint, we get the advantage of that. All the boats rise on the tide. So there's three key business models that we see, and we're going to run through a few of these in a bit more detail. The first one is very much a self-run user, and the best example of this is Canada. And this is very much where you get a conversion of the Flint, you get your own modules, you may get some modules from Mojo Global, you may write some of your own modules, you maintain the IP in those modules, you don't have to hand over the data, you don't have to hand over your science, it's only around the Flint where the licensing is applied. You can then build that yourself, put it on your own computers, attach all your own data and run it internally. And again, Canada is a very good example of this. There may also be a user where you're actually trying to implement an existing system, for example. So in this case, in many ways, the CBM, the GCBM with Chile fits very well in this example here in the middle. What we have is a user. They have taken an existing implementation of the Flint, this GCBM, and with some training provision into that user. So with the collaboration between Canada and Chile, and going through to help Julian, but Julian obviously helping us as well, because he's clearly showing where there's problems or where the system can be improved. That training provider is working with the user and working with Mojo Global. So that's a middle one. It's almost a bit of a hybrid, I think, as we'd say. And then finally, we have the software as a service version, and that is the Flint Pro thing that you saw yesterday. The software as a service version. So this is where we run a version of the Flint online for people. We have a set of configurations that they can use. And so the users at the end, the arrows go the other way. And what those users are doing is they're loading the data into the system. They're using pre-configured configurations. with all of the interfaces, with all of the usability sitting there and ready. And so that user is, and they're still using the Flint, but there's a middle person in the middle, and that's us at the moment. So that is the business models. So I thought we'd just talk through just some really simple examples, and these are by no means complete, but it gives an idea of what you're looking at. And because a number of questions we've had from people is, what would a team look like? What would a team be required to build this system and run it? And the answer to that has been, it depends on what option you decide to go down, and there's disadvantages and advantages to all of them. So if you decide to go down a self-built option, then there's a lot of tasks you're going to need to do. And this is not complete by any stretch, but you can see here, you need to design the system, you need to get the Flint and compile it with the required modules, or download other modules. You need to manage the code updates, you need to implement it, you need to develop all the time series remote sensing products, put all the data in, manage all of the run infrastructure, invest in data storage and archiving and producing the reports. It looks like a long list, but realistically, that's the job of most inventory teams. You could replace Flint with other tools for other sectors, for example. So it's a fairly standard list. For that type of work, here's the kind of team that we're generally looking at. You want someone who's a bit of a policy expert. They could be a technical and policy expert. You know, someone like Werner, who has an extreme degree of expertise in both. They're rare, but you can find them. But you do need someone that understands the policy implications of the decisions. You definitely need, you definitely need a program manager. Who's going to manage all of the contracts? Who's going to make sure things are getting delivered on time? This is often something that's actually missed in a lot of these teams. And in my opinion, it's one of the biggest problems and where a lot of failures occur. A really good program manager will make sure that you will actually deliver on time, and they're vital. It's a real skill set. You're going to need some carbon experts, of course, to help with emissions factors or model parameterization. If you're going for tier 3, you're definitely going to need those people. You're going to need some GIS experts to help with the spatial information. You are definitely going to need some software developers. Those software developers could be a mix of C++, Python, others, depending on how advanced you want to get. And you're going to need remote sensing experts to help do all of the image processing. Now, some of this could still be outsourced. For example, you may outsource the remote sensing products, for example, to a company and do all of the rest internally, or you may decide to do it internally. This really depends on how fast you want to move and how much control you want. I'll put a team size here of maybe 5 to 15 people, depending on size and complexity, noting that if you're going for a very large process of remote sensing, for example, you may, for short periods of time, have 50 or 60 people working on something where you have a discrete task that needs to be done, and then that may come back. So this is more of the core team size that you're looking at managing here, rather than the sort of the surge staffing that you may require at various times. The advantages of these types of systems are that you have full control over when and where things happen, when you update the Flint, what data you put into it. That's all yours. And there is a lot of continuity and institutional capacity and memory. So you really know why decisions were made the way they were. That's actually very, very valuable. The disadvantages are that you'll need a larger team. The implementation is slower. You do actually need to manage all of the software and code. It's not as easy to do, and it will take you more time. The other extreme, so that's one extreme, then there's a whole grey area in between, and then we'll come out to sort of the other side of it, is where you may go down a commercial option. And this is the example that Belize is running at the moment. That just simplifies the tasks. The key message here is that it doesn't take away any policy control. It doesn't take away any control of decision making from the country. All it means is that rather than doing the technical work in-house, you're pushing the technical work outside, but controlling that technical work. You're doing more program management. So in this case, the tasks are more simplified. You don't have the technical tasks. So you definitely need to settle the policy and reporting needs. You'll definitely need to be able to develop the country-specific data that's required. You still need to run the system and get the reports out. You'll need to manage all the contracts and processes, and you'll definitely need to be doing QA/QC. You can't outsource that. You really need to be controlling the quality of the data. and the results. In this case, the example team is much smaller. You still need a policy expert because they are going to be driving forward, what the policies are that need to be considered inside the system. You're definitely going to need a program manager, more important almost in many ways here, especially if you're managing contracts. You'll still need a systems expert. You'll still need someone that understands how and why the system works. You don't want to be completely blind to that. And you'll certainly want someone who's a GIS expert to provide more data into the system. In this case, you probably only need 2 to 5 people, because in some cases, the system expert and the GIS expert may be the same person, and the policy expert and the program manager may be the same person. It's a much smaller team going forward. The advantage are that you get very rapid implementation, and you can start focusing on the results rather than the process, and it can be much cheaper because the team is smaller, and many times the commercial entities are designed to develop these products very fast. They have all of the systems in place already. So an example of the remote sensing group, be it a Space Intelligence, a TerraPulse, many of the other great remote sensing companies out there, is that they've built all of the cloud-based infrastructure. They've built the ability to run huge machine learning algorithms and AI algorithms. They have that there. So that means that they can do it very, very quickly. They don't have to have all of that overhead cost of setting those processes up. The disadvantages is that you definitely need a very good program manager. You have to pay for the software fees. So there is a cost benefit to that. You have to determine whether the saving in one area is offset by the fees in the other. And you do build a bit less in country capacity. That's the disadvantages. The questions, of course, is how much of that capacity do you need? Do you need the capacity in the remote sensing, or do you need the capacity in the mitigation planning and the policy? And these are all the playoffs that you need to think through. In that big grey area that I was talking about, and it is a very, very, very big grey area, there are a huge number of options. And I have to admit, I spent an hour or so today trying to figure out how to show those, and I failed because I couldn't come up with something that described them. So I decided not to try to. What I decided to do was put down some general ideas. The first one that I would hope is very obvious, and it came through in both the previous options, is the policy needs and the reporting needs really need to remain in the control of the national government. When I'm saying a commercial option, I'm not saying outsourcing your policy development and your reporting development. I'm saying outsourcing the processing to get the technical results that you need. My strong opinion is that national governments need to stay very much in control of that, and that the team in charge under any business model needs to thoroughly understand what the system is doing and why it's doing it and how it produces those results. And from personal experience, having done some inventory reviews, even of developed countries many years ago, there were several cases where I was quite surprised that they had outsourced something like a soil carbon model, for example, to a university. And when you came back and tried to ask them questions about how that model was performing and why it was doing the things it was doing, the inventory teams couldn't answer that question. And to me, that was a little bit disturbing, because the inventory team should be able to say the soil carbon is changing because of these aspects of that model. So very strongly, you still need experts under any circumstance. Apart from that, as I said, any and all parts can be outsourced as needed. It's a government and it's a policy decision. The key thing is to not lose control. You still need a team. I put a couple of ideas down, though, that when you start moving down the commercial options to think about. The first one is one that we often hear concerns about in countries, and this is vendor lock-in. So you get a commercial entity to come and do something for you. You're then locked to them. That then provides problems as you go forward because you haven't got any other things, and you get worried that, well, what if they go broke, or what if they start overcharging? And this has been an issue for many years, not just in the land sector and greenhouse gas accounting. It's been considered everywhere from software in health. All of those issues have come through. So considering the difficulty of moving to other providers is important. I think the main point we would make on this is the big advantage of the Flint being open source is that if you can actually move between those implementations. It may not be easy to move between those implementations, but you can actually do it. So that vendor lock-in problem really starts to disappear. The next part is really thinking about the performance criteria that you're going to measure the system against under any circumstance. What does pass QA/QC? What actually meets the performance specifications? If you don't have those in place and you don't have those really clear, it's very easy to get a substandard product, and you won't realise that until way too late. Definitely looking at initial and long-term costs of these. The upfront cost may be much less, maybe the long-term cost is more. Or in a lot of cases, you may find that the long-term costs are actually considerably less, especially as competition starts to come into this area. And really thinking about, do you really need the expertise in-house? The general answer that everyone immediately throws out is yes, but I would suggest to really think through that. A lot of the time you do need it, but what level of expertise is required? And one of the things that we often see in greenhouse gas accounting, especially in the land sector, is where, and if you look up many job ads for this, one of the first job ad requirements it says is must have a PhD. Now that might be useful, but if you're looking for a program manager or you need someone to run a project, a PhD probably isn't a very good thing to have. So I would really think through those requirements. So with that, I've got to the summary and questions point. Have we had any questions or thoughts come up in the chats while I've been going, or should I just plough ahead?
Rob, I think we've been answering most of the questions so far, so I would go ahead at this point, and then we have a block of time at the end where we can answer questions.
Great, thanks. Thanks, Verna. I just turned the lights on in my room. I realised the other night that I was sitting here as it got darker and darker, and I was disappearing on the video as I was talking. So some summary and some questions. Oh, that's not working. I'll just try that. Next slide. There we go. Okay. So Andrew and I spoke today, and we tried to come out with what we thought were the 5 key points from the last 3.5 days that we'd like to leave everyone with. And these were the 5 that we came out with, and that we hope that everyone goes away and understand. The first one is that Mojo is here to support and help you. That's the whole purpose of the community. So please just use us. And don't feel upset. There are no stupid questions, I think is the standard thing, and that is very true in this case. We're also looking for that collaboration piece in the Mojo aspect. So don't forget that even the smallest contribution makes a difference. We have actually had contributors coming to Mojo to fix spelling mistakes in documentation. That is extremely valuable. So even just simple things of you should have put a comma in a sentence, that's a contribution that helps everyone. So we're here to support you, and hopefully you're here to support us. The other key point, Flint is extremely powerful, but it can't do it all. You still need the input data, and you still need the expertise to run it. It makes things much faster. It makes things better, in our opinion. It makes you able to answer far more questions with the same volume of information, and it allows you to have a framework to build on. That's the key part of Flint, but it doesn't end up with just we download the Flint and our problems for the land sector are solved. What we're saying is that you download the Flint and now you can really start to move forward rather than getting mixed up in lots of issues around, oh, do we use this data or this data and these things. Really use it as a framework. It takes a team and it takes collaboration, and working together will make it work. I really hope that to me, that's a really big message from the last few days. All of this has only been possible through collaboration. The only way this is going to continue to work and that we can all get to where we need to be in our land sector greenhouse gas accounting is through teams and collaborations. It's a marathon and it's not a sprint. So start now and build. Definitely don't wait, and just slowly improve over time. And you're just going to get faster and faster and faster and better. You don't just start running a marathon straight away. You train, you might start doing 5 kilometers. You might start doing 10 kilometers. You'll get to 20 kilometers, you'll get to 30. Eventually you'll be running 42s. Eventually you'll be running those in sub 3 hours. And if you're Kenyan, you may actually pull that off in a sub 2 hour. The key part of this is to remember to really think about it in that way. And the final part is we are getting better all the time. Just as I was saying before, it's going to be faster the more people collaborate. I wanted to bring four to five main slides that I picked out of the presentations from the last few days, just to touch on them as a recap and to see if we could spark more discussion, but also really drive home a few key messages. The main one that I wanted to point out here is that this is all cyclical. It all has to happen every 1 to 2 years. It may actually have to happen far more frequently if you're doing more policy analysis for your government. Probably one of the very best examples of that I can think of was many years ago when I was in Canada with Verna, and a whole lot of questions came up around very large wildfires. That was not expected. Suddenly there's a big wildfire and the government's screaming saying, we need to know what the emissions implications of these wildfires are. The huge advantage of having put the information and the effort and the investment into that team over many years was that Verna's team could answer that. They could answer it very quickly, and they could get an answer back to the government and say, here's what we've seen, here's the implications on the greenhouse gas inventory, here's the messaging, here's how, here's what's probably going to happen after this, and if these fires keep going, here's what will happen. That's an extremely powerful thing to have. And that's where you get in, you might be in this cycle, but at any point in time, you can get pulled out and ask these questions. You need a system that's able to do that. You can't have a minister or a government saying, this has happened, can you tell us the answer? And say, yes, we'll get some consultants and we'll tell you in 6 months' time, because 6 months is probably too long. So I just wanted to put this up here to note that an operational MRV system has to be able to meet all of these requirements. It's not just about knocking in and out an inventory. That is a very key component. It's clearly the focus of the UNFCCC. It's one of the key deliverables that has to be done. But think about it in a very systematic way and how you can start really supporting policy development in the future. I don't know, Werner, if you've got any comments there, if I've misquoted you, but I think that's probably one of the best examples I've seen over the years. The other part we wanted to note was the diagram on system design versus system running. So very often, as we said on day one, when you're running a system, you're starting from the top and you're coming down. You're getting data, you're producing products, you're trying to put those products together, and you'll get the information that you need. One of the issues that we have seen in the land sector a lot, and that Flint is trying to solve, is everyone starting with data. So the assumption of immediately we have to go and get some remote sensing data, and we have to go and measure some trees, and we have to go and stratify our forest. Quite often what happens with that, or we just get some existing data sets. What happens with that is you end up with a lot of inconsistent data products that are very, very difficult to integrate. When you do try to integrate them, you actually just introduce more and more error, and you get this really difficult process to try to put them together. So remembering in this diagram, when you're designing a system, you come back. You start with the information, you think about the integration, you think about the types of products that you're going to need to have. You need to iterate on those, definitely, because there's going to be cost implications, time implications, there's going to be technical limitations. And then you go back. Once you've got that design, then you come and start feeding that system down. Coming back to that other point that we've made a few times now, we're adding value to existing data and products. These integration systems, they're not replacing your data acquisition, your data processing, your data products. All of those things still need to get built, but they need to get built in the framework of a design that we were talking about before. And there are lots of really, really good examples and products out there these days that can really help. And they come from everything from the CEPL system of the FAO, for example, through to a TerraPulse or a Space Intelligence, through to your research organisations inside universities, may be able to get that technology and help you implement that and operationalise it. You have your forest inventories, you have lots of ground data, and more you're finding commercial entities measuring things a lot, and so possibly getting access to that data. All of those things still need to happen, but at the end you still need to drag them together, and that's the core part of the Flint system. And of course, the customized design. No Flint presentation would be complete without another diagram with arrows moving between the Flint. And this is just another representation of that. The data coming in, the Flint in the middle, your modules on the outside. You get to decide what's on the outside. That's completely up to you. You can pick up a pre-configured version like a GCBM and just run that. And that is extremely flexible and extremely useful. If you need to add crops and things, you can start adding to that down the track. It's got everything you need ready to go. Producing your spatial outputs and then customizing all your reports. So I have a final set of questions that I'm going to throw out here in a minute. And so what are your next steps? And that's what I'd like to hear in the chat area coming through is, what do you see are the next steps for your country? Is it engaging with the Moja team? We'd certainly hope so. We'd like to hear that. We'd certainly like you to join the discussion and drive the agenda, and definitely test and evaluate the options for using it. But if we could understand, what are your next steps? If you're going to implement the Flint, how do you see that working? Why would you implement the Flint? How would you talk to us? What are your limitations? We raised those questions on day 2. We got a fantastic response to that. We're always happy to take more, but this would be the key part here. Finally, I just wanted to use 2 words, which is actually enjoy it. Without getting too philosophical about all of this, probably some of the most enjoyable times, even though they were extremely stressful, and we had problems and things weren't always easy, that's for sure. But building the Australian system in the 2000s from scratch into something that was running national accounts, that was underpinning carbon markets, that was doing all these things was a fantastic time, and it was really, really enjoyable. And I look back at it extremely fondly. So sometimes when I hear people, it's very, very difficult and isn't it all terrible? Yes, that's true, but it's actually also a lot of fun. If it wasn't, I still wouldn't be working in it, to be honest. So with that, I am going to reach the end, and I think we've actually got plenty of time for questions.
There was one question that I think Werner might like to answer about the sustainability of the Flint implementation.
Yeah, thank you, Andrew. That question was asked earlier and we didn't get a chance yet to respond to it, and I didn't want to respond by typing because it would be a long answer. So first of all, I think we all understand that climate change is real and will not go away. I think the IPCC report has made it very clear that land sinks will be required for us to meet net zero and net negative emissions. The land sector must play an important role in that, of course, along with reduction in fossil fuel emissions, as we have also heard from the IPCC. So it is clear that the need for the tools that we are developing here and that we have developed over the last 20+ years is going to be sustained. And in fact, if anything, demand for these tools will continue to grow. We have, Rob and I and others have made a decision several years ago that we will continue to share with the broader community the 20+ years of development experience that our 2 collective governments have funded for so long. There are literally millions of dollars of investment in the know-how and in the tools and in the software that has been developed. As more and more countries are asking for and using these tools, I think funding agencies, foundations, and governments will continue to provide funding to sustain these tools. I think the best way in which we can achieve sustainability is by continuing to build and grow our community of users and demonstrate the increased value that we can achieve through collaboration. I think we have all learned over the years that hiring a consultant to do the job who then leaves and next year you have to start all over with a new consultant, often with a new data set that is inconsistent with the previous one, is really a futile effort. It's expensive for everybody. And if we can develop collaborative approaches to these problems, we truly have a greater opportunity and a greater chance to address these pressing issues. Particularly in regions where we have a large number of relatively small countries, the know-how about the ecosystems and the ecology in one country does not change at an administrative boundary. The adjacent country has often very similar ecology, very similar ecosystems, and can make use of the modules and the information that is collected. So through an open source approach, we firmly believe that we can improve the collaboration and the knowledge base from which greenhouse gas inventories can be improved in the future. And as long as we have a critical mass of people who continue to use these tools, we will be able to sustain the approach with others in the long term. And just a last point, you know, in our own team in Canada, we have supported the implementation of the old model, the CBM CFS3, for over 15 years. I've run over 30 training workshops with over 1,000 people in many countries around the world. And making these tools available has been and remains a goal of the Government of Canada. So I do believe that there will be sustainability of funding. Of course, you know, there's always an election. There could always be a new approach. But you know, as long as we have a large enough community of users, we will find countries and foundations that will continue to support this. So that was a bit of a long answer, but I hope you can see the merit and the vision of what Moja Global is trying to do.
Just quickly on the sustainability point that Werner made, there was one point there that he made that I think is really important, because what the Government of Canada has done in supporting the CBM CFS3 is truly amazing. It's a long-term level of support that no other country has provided in the world to other countries.